Coming up on the next episode. Good evening, YouTube. It is Friday. It is 8:13 now in the PM. I am here with you on our last MFP update / it's all done video. This may be a long video. I don't know for sure, but what we're going to do is going to go over some things I have outlined on my computer. I spent most of the day, well actually I did some other stuff, but this morning when I got up I didn't even go into the living room. I just started working on this right away because there were some things I wanted to get done before I forgot what I was doing. So this is what I'm doing. And so here's the things I've got on the computer. I'm going to go over this again probably in the living room, but we'll just sort of do a quick one. Basically, this is a list of things that are not done yet on the MFP. Wiring, under wiring, we got put power connectors on both AC adapters. Now those have not been done. In fact, these have not even been got out of the box. They're still in the box. Both of those are still in the box. I said for the meter. Now that's the meters. The one for the 2 amp, it has been done. And I'm going to show you that. That's why it's not on the list, if you were wondering. But it's kind of hard to do. There's the 2 amp one right there. You can read it there if you want. Anyway, that goes around here and comes out over here and is joined to a connector here. I've got the connectors going in and out and around and through here. And it goes over to the, this is the output of the, actually the input, I'm sorry, of the little buck converter. That's where it goes into. And that's what feeds it. Now, that's that. I do have that done. So, that's why it's not on the list. And so, moving on to the next item. Add power connectors to each component. Now, that is something that has not been done. I do have one done, and that is the component tester. I have that one there, and I have this one here, which will also connect to that and make it run. Be helpful to probably put it on the right way, but that one goes there, and that will power the component tester. So that is done, but that's the only one, I think. The rest of these, this is the one for the frequency counter. It's obviously not done. The ones for the scope is over there. It's not even done. It's not nowhere near done. So that leaves the function generator. Now the other item that is done is the what do you call it? I'm gonna show it to you. This is the BDST. You guys may remember it. But there it is. It is mounted, and here is the power connector here. It's mounted. It's done. It's got a lead off of the DC bus. That's what I'm calling it, the low voltage bus. And it's also got a speaker connector right there. And I'll show you why it's got. Let me show you the front of this first. You'll see it later, but I want to show it to you now. There's what that's going to look like. I don't have the knob on it, but I didn't put a panel in. I just figured, you know, it's just easier to do this way. Very simple to do, so nothing complicated at all. So I'm going to just do it that way. That will work. And that's that. Now, on the other end of that speaker wire is going to be a... This is the way it stands up this way. And there you go. There's the speaker. That's what's on the other end of that. And this is a, I think, 3-inch speaker is what this is. 8-ohm speaker. 2 watt. There's our connector for that. That will go with that connector on the board. It comes off the board. And so that's that. So that should provide some decent audio. Now this is a custom grill I made on the, obviously on the 3D printer. And I made it very, very, very shallow. I think it's a millimeter is what it is. So I wanted it to make sure it would fit, because it's going to butt up against that, back there, against that yellow and black Variac control center. And it's a little over half of the speaker will be out in the open where it can be heard fairly easily. So I'm not worried about that much. But I just wanted to make sure it's going to fit in there. That's basically how it's going to fit in there, like that. You can see, if you look over here. Anyway, that's going to work out good, whatever the case. I just wanted to show you that it did fit in there pretty easy, even with the grill on there. So that's that. So that's that part of it. The rest, like I said, the rest of the components need to be wired up as far as connectors are concerned. So that's that. Now, next on our list, it says add wire to connect the signal tracer power from buck converter board may be done. Now, I didn't do it that way because this buck converter board would get kind of crowded if I started routing things to it. As it is right now, I have my low voltage bus being fed from this right here, and that goes into this hot side of this bus, and this bus joins to this bus over here from this connector here. That makes all these switches hot. And of course the bottom sides all have connectors like this on them, and they are what has to be wired into or connected to the component sides of the connectors, which have to be put in yet. And that's what I was talking about in the previous one. So that one there can be wiped off and gotten rid of. It doesn't need. Add connector to component tester and connect to 9-volt DC. That's done too. So the bottom two there can be wiped off. Variac, double check Variac pin 1 connections. Now, I think the reason I had that in there is because of the, that's one right there. So the reason I want to check that is because I have a certain way of doing it here, and we'll look at the other diagram there and see how it's done. But I think what I did was, I'm pretty sure I know how I did it now, and I think that's going to be fine. So I'll make sure later on, but I'll leave that on the list for now. Check that 9-volt ground bus is complete, and that is complete. That's also a bus. These are the bus connectors here. I think you can see this, I hope. Each one of these power leads that go to the various components have a ground side, and it's all joined right here through a, this is a combo male-female spade, and that's what joins everything together. And then, like I said, that's how we did it. So there's our female, or male and female, I should say. That's the one going to the, I believe the component tester and the signal tracer is those two right there. This one here, I'm not sure how that was connected. There it goes right there. Boy, that one's tight. Anyway, that's connected right there. It will come apart if I pull hard enough. But that's all ground wires, and they all go to where they're supposed to go. And so that is done. So now under miscellaneous, I still have to put the Velcro or find the Velcro. I haven't been able to find the Velcro. I do have the top on the terminal block. Over here I have the top on, just using 3 screws. There's no sense in having six screws for that top. It's just really unnecessary. So that is that. Wire all inputs and outputs to components. Now that's going to mean the, just like on here for the, and I'm thinking about just using this as a, using that to wire directly to the BNC. That is the input for the frequency counter, because that's what it was supplied with. And I think if that's the case, then, you know, it's going to work all right just using it. So we'll try it and see. If I have to go to a coax, I can go back to it later. These will all come out pretty easy and be able to, you know, change things around if I need to. So that's why I've got everything that plugs in. That way, you know, if I need to change something, I can unplug it and change it, and then I'll be all set without having to tear the whole thing apart. Or not the frequency counter, frequency generator, function generator. is another one that's doesn't have to have a lot done. It will have the power connected over here. I'll have to figure out which ones of these are the power. I think it's this one and this one, because most of these barrel connectors are alike. The front one's the ground and the back one is the hot, and I think that's how that one works as well. And like I said, the output for that is on this side, and this one will have to be wired into the switch, and that's the next instruction. I've got wired the switch in for the sawtooth and sine wave switch into the function generator. So there'll be 2 wires coming off of there for the switch, and then there'll be a ground wire also. Let's see, I'm not even getting this up. 2 wires coming off of this for the functions, or the sine wave and the sawtooth, and then the ground wire. So, and that will all go to, the ground wire will go directly to the BNC out, and the 2 wires from this will go to the switch, and then it'll go over to the ground wire. So, or to the BNC, hot side of the BNC. So that's how that's got to be done. So that's all ready to go. Just got to wire it in. If I didn't show you this before, this is the connector for the DMM. It's done. I don't think I'm going to use the this board here at all. It just, again, it saves a lot of time and space if I can just get away without that. And the only thing I'll have is our little buck converter, and I'm going to try to find some way of putting this in something that will allow it to be isolated from all the rest of the stuff, and not get any harm of shorting out or anything like that. So, wiring the LED and resistor. Now there's one thing I haven't done yet, and I've got my LED over here. I'm going to use this green one. I've got to find out which one's is the right side and put the resistor on it, and it will go into this little socket here. That's things that, like I say, have to be done. I'm not going to do any more tonight. The last thing on that list is double check all the wiring and put it all together. Now, yeah, that's a job right there that's going to take a while. So I'm going to leave you guys be, and going to get off here and get some other stuff done. We'll see you on the next segment. Good afternoon to YouTube. It is 12:44 now on a Sunday afternoon. I am I thought I had everything done. I really did. I'm going to flash up the picture. This is what I've got done. You can see there's the only thing is check all the wiring and install it, I guess. And that's pretty much all that's left, except one thing I kind of forgot. Being as I'm not using that other board with the things on it, I really need a place for this, and I'm thinking right here, but I need a little 3D printed box for it to fit in. Anyway, I did not use Velcro. I ended up using glue. As you can see, that is glued just fine. I used 4 screws in it and turned askew the box just a little bit, and that will fit in there just fine. It's set up overnight, so it's good and solid. I think everything is pretty much done. Now the hardest part is yet to come, and that is fitting all these wires in and making sure they go to the correct place. That is something I'm kind of dreading doing, but I'm to the point right now where I'm taking a break, have a little lunch, and I don't usually eat lunch, but I think I am today. I have some burritos in there. Have a little lunch and relax a little bit before I'll probably take this in here to the living room and measure it and get the box designed, start printing that to where I'll have it. There's not going to be any top on it. There's not going to be any top on this. It's just going to be sitting down in there to keep it basically out of the way of everything else, and you know, so it doesn't short out if something gets knocked around or something like that. So that's all that's going to be for. And like I said, it'll work just fine that way, I believe. This one sure works real good that way. So I went back and forth so many times on this, trying to decide how to do this. And I just think what I've been trying to do is just go through the things I know need doing, and, you know, leave the whatever is left. And then we'll have to work on it when we come to it. And that's about all I know to do. So Good Sunday afternoon to you all, YouTube. Maybe I should say evening. It is 6 p.m. So this is the third segment of the MFP wrap-up video. Again, I told you it was going to be long, and this is what it is. This is all done. And when I say all done, I use quotation marks. I can't hardly do quotation marks, but you know what I'm talking about. It's done as far as the wiring is concerned. We'll put it that way. As far as the wiring goes, there are certain parts of this that can be wired that don't affect anything else. I'll give you an example. Is these here? These are the high voltage winding from the transformer that will feed the high voltage filter rectifier here. And basically these go to each other like that, and those can be put in, and there's no problem with that. And that just leaves these wires to connect for the power input from the Variac. So that can be connected. What I'm going to do on this, now there's going to be these barrel, or what do they call them? Barrel connectors? Bullet connectors. Don't seal enough to where there's no chance that this, can get, there's no chance that that can short out. So what I'm going to do is take some shrink wrap. I've got some fairly large pieces that I can put over these after I connect them up, and I'm not going to shrink them down enough to where they can't be removed, but that will at least hold them in place and keep things from shorting out, I think. And that's the plan anyway. So I'm going to do the same thing with these here. These are the DC outputs. So that should do that fine, I think. And I can go ahead and connect those, because this is the wire for that. And this goes to the meters, to the Variac, or the DC power supply meters. And as you can see, there's the two connectors for it. So that'll be connected, and those will be done exactly the same way with the heat shrink over the top of them, and that will just leave this hanging here. And then once I put the actual MFP on it, I'll be able to just put these up through the hole there in the MFP where the meters go, like that, and then I can hook the meters up and do all the stuff I need to do there. And so that's going to be working out really good, I do believe. Any stuff that I can do as far as hooking things up and not having to worry about trying to get over things to hook things up, that's what I'm trying to do, and that's what I'm going to do. And I think that's the best course of action for this, because there's just so much here to do. You have to do what you can do when you can do it. Does that make sense? I hope so. So anyway, that's how I'm wiring this thing. The MFP panel itself will be put together, I think I've already mentioned this, with the ends in place and get them screwed in like they can screw in. And I'm going to add a screw or two to those so they'll be more steady without being attached to anything else. And so got to do that. So I'm going to get off here, and probably will come back one more time at least with the wiring of this. So stay tuned for that. Good Monday afternoon to you all, YouTube. It is 12:37 now in the PM on this day. I'm here back on the, what do you call it again? I know I said what do you call it. This is the MFP. We all know what it is. Why should I need to remember that? As I told you before on the previous segment, I planned on doing this, and this is what I've done. These are the high voltage for the output of the transformer, high voltage output. This will be up to, say, 480 volts here, and I decided to go ahead and bridge the across there with the heat shrink, and that way it keeps, there's no chance that they're gonna have a problem touching something, because there was just a hair, I mean not very much, but there was just a little bit of an exposed metal between the two bullet connectors. So I thought, well, this is the way to go. Did the same thing on the high voltage DC out. This I've used just a little bit tighter on this. but these are the same type thing, and these are the wires that go over to the meters. That'll be the one for the voltmeter there. This will be the one for the ammeter down to bottom. And there's our output for that. Now you can see I've got this colored black because this is actually the negative wire. Now this is just the way this meter was designed, or I don't know why it was designed that way, but that's just the way it works. And it has the red going to the minus, because the meter itself measures the current on the negative side of the rail instead of the positive like most do. So I don't know what difference that makes, but it does make a difference. So I'm doing it like it says in the wiring diagram, and we're going to go from there. So that's that. There's our there's our positive one right there. It goes back over here just like I say, just back to where it comes from. I can get these out amongst themselves a little bit. And this is our meter power. It also goes to the meter connections, which will be added to this as well. I plan on getting this all done. I'll wire in the meter connections to this, and then I'm going to try to hang that off a certain way off the back here, so I can, in other words, when I put this in, it will just sort of hang in the breeze. This will all go up to the, this will go in with this bunch here. There they are. These are going to the variac connections, and that's where they go. And so that's that. And I'll bring you back if I have some more. Alright, it is 1:55 now in the afternoon. As you can see, I have made progress. Basically, the MFP is together as far as the bottom and the top is concerned. I have this wired pretty much all the way done. I don't have it all screwed in, just have one screw holding it in place. This is one of the wires that goes to the meter, and the other one is under there somewhere, and I think I can feed that around there through there pretty easily, I hope. And that's what I've got to do. I want to get all that fed first, and then I'm going to start working on this. This is the low voltage stuff. I say low voltage, this is actually line voltage here for the filament transformer. That'll have to be put in. But as you can see, I have the leads. Let's see if I get you down a little bit more. Got the leads plenty long enough to bring it out to the panel itself, and then we'll just slide the whole thing back in there and screw it in. That should work well, I think. AC or wall warts there. I've got those strapped together like I told you I was going to, and those should hold up pretty good. And again, I probably will attach them some way to the back, but I may just let them hang. Right here's the cord for that, and it will come off of, let's see, this bunch of wires here goes over to that. And there's several wires there. You can see the transformer, or the variac wiring that will have to be done. These all here go to that, and I've got that all ready to go. That goes down to the meter power on the bottom one, and this one will go up to the top. If I can find it, it's in here somewhere. There it is. Oh, that's the meter power. That goes to the bottom. That's got plenty of wire for that. The other one comes up to the top for the top meter to plug into, and I want to try to get most of that done, and then I'll move on over to the low voltage side, as I said. But as you can see, it is screwed in. I have all 4 screws in the back holding the bottom and the top on the ends and all that stuff. So that's good. I'm taking a break now. Like I said, it's going on 2 o'clock, and I think I deserve a break. So that's what we'll do. So, alright, that's going to do my little update. So we'll let you get back to it. Hi, we are back once again. It is 7:35 now in the evening on this Monday. You can probably see what I've got up here. You got nothing down here because there's no current draw. Obviously there's a problem with this meter. I may have to find a new meter. I hope not, because obviously I've got this cut for that meter, and I really don't want to have to print up another one, but I guess I could. Again, I'm going to find something else to try out this, make sure there's some current being drawn, and go from there. So I'll bring you back for that. Alright, well, I just did a test of this radio to find out if the meter works, and it did. And I'm going to redo it again because I didn't have the camera on. Let me do this again, get it up to 14 volts. I think that's what I had it up to. There, right there. And we'll bring this over here. Touch our center, our positive. There you go. Drawing 13, 14 milliamps. That's good. Real good. Voltage dropped about 5 volts when I did that. So it is working. I don't know if I can tune this or not. So there you go. Does work. Let's go up a little bit more. Alright, well that's all I really wanted to do was show that it was working. And we can turn that off, down I should say. And it goes down pretty fast. It's down to 13, 12, 11. So anyway, that's working, and like I say, I just want to make sure that the amperage meter was working, and it is working well. I just got to figure out what's wrong with the voltage meter. I'm pretty darn sure I've got it hooked up right. I checked the I couldn't find the exact meter, or what do you call it for this, but I did find one. It was very close, and I thought it would work, and so obviously I've got something hooked up wrong. But I have had this work before. I don't know if you guys remember it, but I did have it working at one time. So I did a test on it before I even put it in this thing and stuff. But then I played with the jumpers trying to get the decimal point in. I was hoping to use this last segment over here for, you know, 1/10 of a volt or whatever, and do that, but never could get that to work. And I don't know if I screwed something else up or not. But I really like the meter and everything. I'd like to find another one if I could find one, if this one's not going to work. But anyway, it's down to 1 volt now. So I can touch that there, and it goes down to 0. So that's good. It came right back up to 1. Capacitors in there. So anywho, that's a look at the what do you call it again? The filament transformer works fine. I've got some of this over here hooked up. Let's see if you can see a little bit. The signal tracer is hooked up and working. I don't have it plugged in right now, but it is working, and I have tested that. I've tested the LC tester with the pilot light. The pilot light comes on, and I'm sure the LC tester does too. So, you know, that's obviously going to be working if the pilot light's, if it's getting power. I got one little problem I ran into that I didn't know. I don't know exactly what I'm going to do to cure it, and I still don't know yet. Notice the, let me go in here and look a little bit closer at this box. Is the right size, but that was how long that is, that, what do you call it there, and it's not long enough to let that lay down flat. Now it's in there like that. I'm not going to worry about it. I may at some time in the future put a little extension on that or something like that to make it better, but for right now I'm just going to leave it like it is. It's not touching anything. That was the primary purpose of that box, is to keep it from touching anything, so it is working. Again, I've just got to take my time and go through this stuff. Found a couple of problems over here on the variac. There was some of those wires in the back. I've got to see if I can't get that wiring straightened out to where it's not touching that wiper on that variac arm, because it gets caught up in the what do you call it, and then it causes a problem. So I don't want that to happen, obviously. So anywho, let me get this all unhooked, turned off, and everything like that, and get this all uploaded or whatever. Good evening, YouTube. Here with you on this Tuesday evening. 7:09 is the time. I like where that sounds. You can see this looks very done, and for the most part it is. This is where I'm calling it quits for right now. I'm going to explain some more about why. But first, let's go through and check some things out. First thing we're going to do, we're going to start over here, and I have the meter hooked up in the loop because we want to compare this meter with this meter here. We're going to turn on our... Now that comes up in DC volts. You can see 138 millivolts on the meter, and that is the cap, what's left in the cap. So what we're going to do is, again, turn this on. Make sure it's down all the way. It is. Bob's going crazy with the text. And I'll be getting back to him in just a minute. Anyway, let's go ahead and do this. Now you'll watch the meter. Finally, it will clear out and go down to 0. And it did. And as you can see, we still have 815, 16, whatever that is. There's a little leakage current on this, because if you hook the fluke up, it also comes up around the same amount, I do believe. So it's not a big deal, and that's the way that works. But anyway, let's go ahead and put some voltage on it, and we can see there that 49.5, 49 on the other one. Now that's close enough for my kind of work. I tried my best to get the decimal point to work, but it doesn't. It will put a decimal point there, but it just says 4.9 instead of saying 49. So that's that. Now, as you notice, as we go up in voltage, the difference between the two meters becomes greater. There's 141. You can see there we've got barely 140 on the other meter. I can't even pronounce the name of that, but I really like the display on that one. Shows up really good, especially on the camera. So let's go up a little higher. Now we're up to 254 on the variac, our DC power supply meter. 255 and 250 basically. So it's all 5 volts at that range. It's not a big deal. Bob was testing with Bob on this, and he said, it's not that big a deal, especially since you've got a meter right here. If you need a more precise voltage that you're getting out of the meter off the DCPS, it's easy enough to go over to the hook this up cable and do that if you need to. Okay, so that's that. I'm going to say that's good. I've already tested the filament transformer, and we've seen the results of that, I think, on a previous segment, and so we're not going to do that. So let's turn this down, and it'll bleed off. Let it bleed off for a little bit while we talk about some other stuff. This is hooked up. It has been tested. I'm not going to test it again. I hooked it up to my AC variac over there behind that, and I had 6 volts on here. I had 5.9 on that, and it was working just fine. So no other testing needed to be done for that. It works fine. Function generator, when Bob and I were testing it, I couldn't get it to work, but I did not hook it up right, apparently. It's either that or the scope's not working, one of the two. But we're gonna try that out next. And let me turn this off. It's down to 12 volts, 10 volts. It's coming down pretty good. I'll leave the other one hooked up. That way we'll know where it's at. But anyway, let's try this function generator. And on my switches down below here, I don't know how we can see it, but up is off on all these. And we are on that. Down is sine wave, up is square wave for the type of wave it is. And so what we're going to do is turn the signal tracer on, and there is a what do you call on there, and the meter's timing up, but that's okay. You can hear the buzz of the signal tracer, and we're going to turn it on now and see. As you can see, that does work just fine. And the scope, I'm not going to demonstrate that because it's not quite right. It will show a waveform on there, but it doesn't get the doesn't quite get it out where it needs to be to see it. And also, it's very, very difficult to see that. Even standing or sitting right next to it, I can't hardly see it. It's not very bright at all. I'm thinking about replacing this with a different piece of equipment, but I don't know what yet. That was the meter going off. So I don't know what yet, but that's that. I can't test the LC tester. I don't have anything here to test that with. And we've already seen a demonstration on that. Only thing I did was, put it over there and behind the rest of this, and it's just wired into this. The only difference is the frequency counter does not work. I'm going to turn this off. Oops, let's turn the frequency counter on. Turn that off. Okay. I got to remember, to me that's backwards. Frequency counter on. You see there's nothing happening there. Either there's a wire off or something else, obviously. But it's not a big deal. It's only one thing out of all the pieces of equipment that I have going here so far. And the last thing I'm going to show you testing is the component tester. I'm getting a bag of caps out here, and we're going to get one of them out, put it on there, and test it. And just see how well it works. Hook it up there to a couple leads. If I can get a hold of them. They're hard to grab a hold of. Alright, there we go. Let's press the button. You can see it is testing. And I think these are 33s, I think. Pretty sure anyway. E-caps is what they are. There you go. 31.9. That's 32. That's pretty darn close. ESR 0.72 ohms. Loss is 1.3%. So it does work. Works fine. And very happy about that. And we'll take that off. And I'm not going to test anything else. I just wanted to demonstrate the fact that it does work. And that's all we needed to see. Again, I'm still going to, after I get the, I'm going to do some more checking on this frequency counter. And once I get that squared away, like to my liking, in other words, find out what the problem is with it, if it's the meter, if it's the power going to it, or what. I'll fix that. Now this, again, I'm not happy with at all. Things like this happen. Again, I have my other scope. It's not a big deal, but I kind of wanted to have a little bitty scope here. I can see the waveforms on there, especially if I use the square wave function. I can see them on there, but I can't get any adjustment on here. I could take the amplitude here on the function generator, go all the way down, go all the way up. It doesn't change anything on here. So that's a problem. So anyway, everything is working except for the frequency counter. Obviously, again, that's probably a problem with the wire. Let me show you what's on the back side, and then you can tell me how easy that's going to be to fix. Let me take this apart first. Get this all done. I don't really care for the way these BNC fits on here because they're hard to get it on and off. Not impossible, just hard. And the same with anything else I've got to hook up. Even the banana jacks are a little bit difficult to get to. Not impossible, again, but a little bit difficult. So there you go. There's a good look at it. Get you some light on here. That's what it is. The frequency counter is way down there, and I've got to figure out what's wrong with it. Probably what I'll do is take that front jack panel off, and that way I can get in there to see it a little bit. I can also take the scope off. It's just sitting there. It's not screwed in or anything like that. So other than that, I'm good to go on this, and I'm very happy. Now this keeps coming up, but not a big deal. Just push it back down there. Partly is because of this here, and I'm going to get this secured. I'm going to secure it in such a way that it stays like that, and then it won't pull that board up and down. Just pull on the strain relief. So that's the plan on that. And again, that's what I'm going to do. But I think I'm happy with it. Like I say, I'm very pleased that it is working mostly. And again, that's the rest of this is going to be, I'm not going to put it back in the hole until I get the frequency counter sorted out and find out what's wrong with it. But that's going to do this. I wanted to show you that the MFP does work, and it is a viable option now to use for different things. And especially once it gets mounted back in its hole, it is screwed in. This is all screwed in. This is all screwed in. The panel here screwed in with one bolt here, here, and here. And that's really the only things I can get on there right now. So that's good. It will work. Again, not happy with that. And the frequency counter, I think that's just a matter of getting it power to it. I think that there's something wrong with our power. I don't know if it's the switch. Could be even the switch. The switch, you know, these were a bag of Chinese switches, so you never can tell what you get. Pig in a poke, you know how that is. But anywho, and I've got to change the fuse here. I've got a 3 amp fuse in there now, and I need to do a 1 amp. I think Bob and I decided that's about the best. So get that in there, and that's going to take care of it. So I thought, let me give you a back view of it. So there you go. That's a real good look at it, and everything works that except for that. And the scope, like I said, it's just a piece of junk. I don't know. You guys can leave some comments on what do you think I should replace that with. Again, it's not even screwed in. It's just sitting in there. Of course, it's got so many wires on it. Everything else, it's not easy to get out, but it will come out. Like I say, it is what it is. Let me give you a look at the front panel. There you go. There's a good look. Let me go over the things here. That's fused for the DCPS. You got your outputs for the DCPS, positive, negative. Switch for the DCPS. This is our AC voltmeter up there. This is our sine square wave. Top is square, bottom is sine. There's our output for the function generator. There is our on-off for the function generator. Again, everything on is down. I've got this one left on, but that's okay. So that's off now. This is our frequency counter, and that's our input for it. Our filament voltages come out here. 6 volt, 12 volt, and on and off. And this is our scope. Input for the scope is here. LC tester. Output for the LC tester is here. Of course, our signal tracer input here, and our on-off volume for it there. That's pretty much it on that. So, again, thinking of a better way of doing this, some way that I can maybe print a different kind of a panel that will come out like this and allow me to get squared off inputs like this, squared off like down here, only like halfway down instead. So anyway, that's something I'm thinking about. Not a big deal one way or the other, but again, I'd like to have it easier to get things on and off if I could. But this will work. This is not the end of the world because it's a little bit hard to get those on and off. Bob suggested putting something underneath the front of it, which is another possibility. I'd have to put, make some kind of a thing that would go all the way around the edges of it too, and come up at an angle or something like that, which, that would work. Good possibility. I don't know, we'll have to see. But I'll have to come up with something. But again, that's part of the, you can plan until you're blue in the face, But when you comes down to doing it, then there's always some problems that will arise, and so you just have to do the best you can with what you got when you got it. And again, that's just it works like I want it to work, and again, happy with it. So that's going to do me on this one. This video is going to be posted very soon. I'm going to work on it this evening. Don't know that I'll get it up for tomorrow, but I hope I do. I've already got the first 3 segments done, and like I said before, I'm going to try to take out highlights of those and just use the highlights, because this thing would be over an hour, well over an hour long if I didn't. So I don't think it's going to be that long, but it is going to be longer than usual. So just warning you. Of course, you won't hear that until the end of this, but all right, I did warn you in the beginning of the first segment that it was going to be a long one. So that's going to be doing me right now, and happy with, again, everything that's working like it is working, and just got to figure out that one and think of a better alternative for that scope. So that's it. You guys have a great night. Thank you so much for watching, and we will see ya.